In this video, we are going to discuss about some objective questions based on lithium aluminium hydride and sodium borohydride. Before going to solve that questions, first we should know what is aldehyde functional group, what is a ketone functional group, what is a ester functional group, what is a cyanide, what is a amide. See now, RCHO functional group is there, means it is called aldehyde functional group. RCOR means ketone. RC double bond O is there, means it is called as what? An ester functional group. RCN is there, means it is a cyanide functional group. RCONH2 is there, means it is called as an amide functional group. Identification of functional groups. Okay, now we'll solve the questions. Now in the first case, question number 1, see now here R C double bond O is there. Now this is called as what? An ester functional group. Next RCOR, this is called as what? An ketone functional group is there. Now this is reacting with what? First sodium borohydride followed by hydrolysis, and then what we are going to get the products. What is the answer? Yesterday we discussed sodium borohydride can reduce only aldehydes, ketones to alcohols, but it cannot reduce that what? Esters. So therefore what we can write here? It can reduce only ketones and aldehydes. It cannot reduce esters. So therefore ester functional group as it is we are writing. Ester functional group as it is we are writing. Now ketone functional group, just you break the bond, yesterday we discussed, just you break the bond, here 1H, here OH. Addition of hydrogens. Okay, now we are going to get this one. Next here what we are going to get? The same compound reacting with what? Lithium aluminium hydride, then followed by hydrolysis. What we are going to get the product? Now already we know this lithium aluminium hydride reduce ketone groups to what? It can reduce ketone groups to alcohol. So now this is the ketone group. Next the compound is this one, C double bond O CH3. Now reaction with what? A lithium aluminium hydride. First it is reacting with lithium aluminium hydride followed by hydrolysis. And then what we are going to get? First you break the carbon oxygen bond, then you write here H, write here H. Then what we are going to get the product here? Now OH, H. Next lithium aluminium hydride can reduce ester functional group also. Now ester functional group means what? Break the carbon oxygen bond here H, here H. Next break this double bond here H, here H. Then finally what we are going to get? R CH2, CH2 OH, CH2 OH plus CH3 OH, CH3 OH. Yesterday we discussed esters are undergoing reduction, will get that what? Two types of alcohols, because here this carbon is different, so therefore two types of alcohols we are going to get. Sodium borohydride cannot reduce ester, but whereas lithium aluminium hydride can reduce the ester. Next question. Now this is an acid functional group, right? Now this is RC double bond OH, acid functional group. Acid functional group reacting with sodium borohydride, no reaction, because sodium borohydride cannot reduce that what? An acid. Whereas lithium aluminium hydride, so now this is the lithium aluminium hydride, CH3 C double bond OH. Now lithium aluminium hydride can reduce that what? An acids. Now break this carbon oxygen bond, here H, here H. Then what we are cutting? CH3 CH OH OH. Two OH groups present on the same carbon, highly unstable, so therefore elimination of water. Then we are going to get that what? CH3, C double bond O, H, aldehyde. We got aldehyde. Again aldehyde is reacting with one more time this lithium aluminum hydride in the presence of water. Then break this bond. H, H. Then we are going to get that what? CH3, CH2, OH. Simple is just you convert this acid to alcohol. Acid to alcohol you can write. Okay. Now you try this question. Here ketone functional group is there, acid functional group is there. Reacting with sodium borohydride, reacting with lithium aluminum hydride. Ketone acid is there. You try. Now direct. The sodium borohydride cannot reduce an acid. It can reduce that what? Only ketone. Lithium aluminum hydride, it can reduce ketone as well as it can reduce an acid. So now I will write lithium aluminum hydride, EME. CO group is converting into what? CHOH. Just you break the bond, HOH. Next, this CH2 as it is. Lithium aluminum hydride converting an acid to what? Alcohol. COH is converting into CH2OH. This is the answer. Whereas sodium borohydride, it can reduce only ketones to alcohol, secondary alcohol. Whereas COOH is as it is present because it can't reduce. Now here OH. This is the reaction. Next, this is ester functional group. This is aldehyde functional group. What about the lithium borohydride and what about the lithium aluminum hydride? You try that question. Next, question number 5. Now, this is what ketone functional group. Alkyl halide is there. This is the carbon halide. What is the reaction with sodium borohydride and lithium aluminum hydride? Now already yesterday we discussed lithium aluminum hydride is converting that what? An alkyl halides into alkanes. Alkyl halides into alkanes. So therefore, what we are going to get? Now C double bond O group is converting into an OH group. Break the bond, H. Next, an alkyl halide part is converting into what? An alkanes. Alkyl halide is converting into an alkanes. What about the sodium borohydride? Sodium borohydride cannot converting alkyl halides to alkanes. It converting only the ketone groups into what? Alcohol. What about the alkyl halide? Alkyl halide is as it is present. This is. Next here double bond O is there. Double bond O is there. Alkene is there. Sodium borohydride or lithium aluminum hydride cannot reduce that what? A carbon-carbon double bond. It can reduce that what? Only the CO group into what? Alcohol. Ketone group is always converting into what? And secondary alcohol. Either with lithium aluminum hydride or sodium borohydride. Just you break the bond. Here H you can write. So therefore CHOH, alcohols. Next, lithium aluminum hydride, sodium borohydride. Question number 7. Now this is NO2 group. Yesterday we discussed RNO2 group. Whenever it is reacting with lithium aluminum hydride followed by hydrolysis, the NO2 group is converting into what? The NO2 group is converting into an H2 group. Whereas, what about the sodium borohydride? Sodium borohydride cannot reduce that what? An ester. Cannot reduce a nitro group. Now this is aldehyde. Now finally what we are going to get the answer here. Now I am writing only with lithium aluminum hydride, which is followed by hydrolysis. Then we are going to get that what? Now aldehyde. Aldehyde is converting into an alcohol, primary alcohol. Next, NO2 group is converting into an amine. NO2 group is converting into an amine by the reduction. This is a reduction reaction. Removal of oxygen, addition of hydrogens. Then we are going to get this. Next, this is what an amide functional group. This is what an amide functional group. Yesterday we discussed whenever amides are reacting with lithium aluminium hydride, then what will be happen? Break this bond. Now here 2 hydrogens, here 2 hydrogens. Then we are going to get that what? pH, CH2, NH2 plus water is eliminated. See, now this group is converting into an CH2 group. Amides. This is a amide functional group. Whenever they are reacting with a lithium aluminium hydride, break this bond. This side 2 hydrogens, this side 2 hydrogens. Then we are going to get that what? An primary amine. These reactions, lithium aluminium hydride, sodium borohydride reactions, very important for JEE mains and NEET, and also it is also more useful for conversions reactions. How we are converting amides to amines. Then by using lithium aluminium hydride, whereas sodium borohydride cannot reduce amides to amines. Only lithium aluminium hydride can do. Okay, next you try this question. This is anhydride and this is alkene is there, carbon-carbon double bond is there, CO group is there, carbon-carbon triple bond is there. Either sodium borohydride or lithium aluminium hydride cannot reduce carbon-carbon double bond or carbon-carbon triple bond. It can reduce only the ketone groups into alcohols. Only this part, this bond is broken. Now here 1 hydrogen, here 1 hydrogen. Then we are going to get alcohols. Next, here what is given? An acid chloride is given. So now this is RCOCl. RCOCl, acid chloride. Acid chlorides cannot reduced by that what? And sodium borohydride, because it is a weak reducing agent. Now whereas acid chlorides are converting into what? Just you break the bond. Here H, here H. Next you break this bond. Here H, here H. Now finally what we are going to get? Acid chlorides are converting into what? CH2, CH2. Next CH2, now CH2, CH2OH plus HC. Now we are going to get this. Just break the carbon halogen bond, HH. Next break carbon oxygen double bond, HH. We are going to get this. Like this you can break. Now R, C double bond O, Cl. Now break this bond, H, H. Next break this bond, H, H. So finally how many? R, R, C, H2, CH2, single bond OH, single bond OH plus HCl. Like this. Alcohols are converted. Next. Now this compound is given sodium borohydride followed by hydrolysis they given. So now whenever here sodium borohydride, what is given here? H. Sodium borohydride containing H. Generally the sodium borohydride is providing that what? An hydride ion. It is providing an hydride ion. Now this H2O means it is giving that what? An H plus ions. Now what will be happen here? First this bond will shift this side. Then we'll get that what? Minus. This carbon is plus. Now what is going to be happen here? This H minus will added here. This H minus is going to be what? Add. That means here we are taking hydrogen, means that hydrogen is connecting to this what? Oxygen connected carbon. Now CH2 CH3 we written as it is. Next this is O minus. This water will give what H plus ion, no? So therefore that OH. Like this the C double bond O group is converting into and CHOH group. C double bond O group is converting into this CHOH. Same way the same compound reacting with what? Same compound reacting with lithium aluminum hydride followed by deuterium oxide, that is D2O. Same. Whenever they are asking the questions in this pattern, then you have to solve the questions are like this. You have to solve like this. Now these electrons are shifting. Now this is the minus, this is the plus. Here what is given? Lithium aluminum hydride. Now see, now lithium aluminum hydride is given means it is always providing that what? Hydride ion. Instead of hydrogen, if they given deuterium, lithium, they give D minus. Okay. Same way, whenever they given sodium borohydride, they always gives that what? H minus. Okay, now sodium borodeuterate is given. Instead of hydrogen, its isotope is given. You take minus. Next, if water is given, you add H plus to the oxygen. If D2O is given, deuterium oxide is given, you add D plus to the oxygen. Or instead of water, if they given any acids, H plus you should add. Okay. And now solve this question. Now here, now they given what? Lithium aluminum hydride. Lithium aluminum hydride means it is providing that what? H minus. So that H minus you can add here, because carbon plus H minus. Next, here what is given? D2O. D2O means it will give what? D plus. The D plus you can add here, because oxygen is a minus. This minus, this plus is going to be what? Combined. Then we are going to get that what? CH3, CHOD, CH2, CH3. This is our final answer. Okay, understand? In this way you can solve. Any question is given, we can answer this. Like this you can solve the questions. Next, the same way, try this question. Here what is given? Lithium deuterate is given. So that means here it will give that what? D minus. Lithium aluminum deuterate is given means D minus. The D minus, this D minus connected here. Next, water is given. Water means H plus. Here you can add H. Then what we are going to get? CH3. D will be added here, no? So therefore CD. Here H plus is given, oxygen having negative, no? So therefore OH. Now we are going to get that what? CH2, CH3. Next, here also what is given? Deuterium is given. That means it will give D minus. Now this D minus where we should add here? Here positive, C double bond O group. Positive, oxygen is having negative. So this D minus will add here. So therefore CH3, first reaction. First reaction with lithium aluminum hydride. So therefore D. Next O minus, CH2, CH3. Next step is what? It is reacting with D2O. D2O means it will give what? D plus. D2O means it will give D plus. Now oxygen is having the minus, no? So therefore you can add here. Then we'll get the answer is this. Like this you can solve the questions. Now this is test yourself. Now I am given this compound. Now same reactions I given. Sodium borohydride D2O is given. Lithium aluminum deuterate is given. Water is given. Lithium aluminum hydride H plus is given. Now you try and check. Thank you.